In 2019, a small team of ecologists drove a convoy of saplings into the Scottish Highlands and planted them in soil that had never, in recorded history, hosted a tree from California. The saplings were giant sequoias, the largest trees on Earth, and the scientists knew the odds looked absurd. These were trees that evolved under Mediterranean sun in the volcanic soils of the Sierra Nevada at elevations above 5,000 feet. Scotland is cold, wet, often wind-swept, and geologically nothing like California. And yet, 6 years later, those trees are not just surviving. They are thriving. Growth rates at several Scottish test sites are tracking ahead of comparable sequoias in their native California range. Some trees have put on height faster than the long-term Sierra Nevada average. The researchers monitoring them are cautious. It is early, and the full story will take decades to tell. But what is emerging from these highland planting sites is forcing a serious rethink of where giant sequoias can survive, and why Scotland might be better prepared for them than anyone assumed. To understand why, you have to understand what a giant sequoia actually needs, and what California is slowly losing the ability to provide. Giant sequoias are not delicate trees. In their native range across a narrow 420-kilometer strip of the western Sierra Nevada, they live through hard freezes, deep snowpack, summer drought, and periodic wildfire. They are built for extremes. The oldest confirmed individual, the grizzly giant in Yosemite, is estimated at over 2,700 years old. General Sherman in Sequoia National Park holds the record for the largest living tree by volume at over 1,400 cubic meters of wood. These are not fragile organisms. What they cannot tolerate is prolonged heat combined with moisture stress during their early decades of growth. Young sequoias need consistent access to soil moisture through their critical establishment phase. Their root systems are surprisingly shallow for their eventual size, spreading wide rather than drilling deep, so they depend on soils that hold water reliably through dry seasons. Seedling survival is the species' most vulnerable bottleneck, and it is precisely at this stage that California's changing climate is doing the most damage. Drought conditions in the Sierra Nevada have intensified significantly over the past 2 decades. Between 2012 and 2021, California experienced its driest period on the entire instrumental record. Bark beetle outbreaks, accelerated by heat-stressed trees losing their resin defenses, killed an estimated 19 billion trees across the state during that stretch. Sequoias that had stood for centuries were dying because the soil beneath them could no longer hold enough moisture to sustain them through the summer. Then the fires arrived in a form the trees had never encountered. In 2020, the Castle Fire burned through portions of Sequoia National Forest and killed an estimated 7,500 to 10,600 mature giant sequoias, roughly 10 to 15% of the entire global population in a single event. The following year, the KNP Complex Fire and the Windy Fire burned through additional groves and pushed total losses from just those 2 years to somewhere between 15 and 20% of all mature individuals on Earth. The sequoia's relationship with fire is ancient and essential. Their cones are serotinous, sealed shut under normal conditions, and they open and release seeds in response to heat. Fire clears the dense duff layer that otherwise prevents seeds from reaching mineral soil. Low-intensity burns have historically been part of the cycle that allowed sequoias to regenerate. But the fires of the 2020s are categorically different. Fueled by a century of suppression that has loaded California's forests with unprecedented fuel loads, and then amplified by drought conditions that have dried those fuels to historic lows, modern Sequoia Range wildfires are burning at intensities outside the range of anything these ecosystems evolved to survive. The soil temperatures in severely burned areas exceed the germination threshold. Seedlings that do emerge face summer heat anomalies that their lineage has no adaptation for. The question researchers began asking is straightforward and uncomfortable. Can the Sierra Nevada continue to support giant sequoias through the coming century? And if the answer is uncertain, what should be done about it? Scotland's climate, it turns out, offers something California is increasingly unable to guarantee: reliable moisture delivered consistently across the year. The west coast of Scotland receives between 1,500 and 3,000 millimeters of rainfall annually in the regions where experimental sequoia plantings have been established. More importantly, that rainfall arrives across all 4 seasons, rather than being compressed into a single wet winter period, followed by a long, dry summer. Scotland's maritime climate, moderated by the North Atlantic and buffering temperature extremes in both directions, means winters rarely deliver the sustained deep freezes that cause ice crystal damage in tree tissue, and summers rarely produce the weeks of combined heat and drought stress that are now killing young sequoias in California. The soil conditions at several Scottish sites have proved more compatible than expected. Sequoias prefer slightly acidic soils with reasonable drainage and accumulated organic matter, conditions that overlap significantly with upland Scottish soils developed under centuries of moorland vegetation and mixed forestry. Critically, these soils retain moisture at depth even through dry spells, providing the consistent water access that young sequoias require during establishment. The longest-running evidence comes from Benmore Botanic Garden in Argyll, where sequoias were first planted in the 1860s. Several of those Victorian-era trees now stand at heights of over 40 meters, and they continue to grow. They did not die. They did not decline. They established and grew steadily for over 150 years through Scottish weather, without any of the irrigation, soil amendment, or intensive management that struggling California seedlings now require. Benmore is not an anomaly. It is a proof of concept that the experimental plantings from 2019 onward are now being built on with scientific rigor. Researchers are currently collecting data on which specific highland soil types produce the strongest early growth, how competition from surrounding native species affects sequoia canopy development, what the minimum rainfall distribution profile needs to look like to sustain a seedling through its first decade, and how the trees respond to Scotland's notably different photoperiod compared to California. Early results from monitoring plots indicate that trees planted in sites with free-draining but moisture-retentive soils, at moderate elevation and with some shelter from prevailing westerly winds, are performing best. None of this comes without complication, and the debate around it is serious. Giant sequoias are not native to Scotland. Planting them at scale raises legitimate questions about ecological displacement. At full size, sequoias cast deep shade, and they substantially alter the understory conditions of any woodland they occupy. Their root systems and leaf litter chemistry influence soil biology in ways that affect native invertebrates and ground flora. Scotland has limited land available for tree planting, and strong arguments exist that this land should be directed toward restoring genuinely native habitats, such as Caledonian pine forest, Atlantic oak woodland, and riparian corridors, rather than importing Californian giants. The counterargument is rooted in scale and urgency. The giant sequoia lost an estimated 20% of its mature global population in 2 fire seasons. The rate of natural regeneration in fire-affected Sierra Nevada groves has slowed dramatically, as post-fire conditions have become less hospitable to seedlings. Without active intervention, both inside California and beyond its borders, the trajectory for the species is poor. Established populations in Scotland, even small ones, preserve genetic diversity, support research into sequoia biology under different conditions, and represent a form of distributed insurance that no amount of in situ management alone can provide. This is the logic of assisted migration, moving species ahead of the climate conditions they can no longer reliably survive in their native range, and it is a strategy conservation biology is increasingly being forced to consider for dozens of species simultaneously. Scotland is not being asked to save the giant sequoia on its own. It is being asked to be part of a network of sites across Europe and the Southern Hemisphere where sequoias can grow while their native range undergoes a period of profound instability. The Highlands are one node in that network. The trees at Benmore, some of them now over 40 meters tall and still growing after 160 years, make a quiet and persuasive case that this particular node is well chosen. The experiment that nobody expected to work is working. The researchers watching those highland saplings add height and girth in Scottish rain are only beginning to understand the full scale of what that might mean for the trees and for the forests they might one day anchor.